Hello and welcome to SMTconnect. My name's Bob Willis and we're here with Winnie TV and we're talking to Thorsten and from Heraeus, and perhaps you'd just like to introduce yourself and what you're focusing on at the show this week.
Yes, I'm Thorsten Vehoff. I'm the head of technical solution management for Heraeus Electronics, and we're here mainly to promote all our die attach and also metal ceramic substrate products, so everything from sinter paste, solder paste, bonding wires, die top systems and substrates. And one of my main interests is also connecting with our main customers who are all here, ranging from the tier 1 automotive suppliers to people delivering into the photovoltaics industry.
So we discussed about your previous experience in manufacture, which is great, and it brings you into working with a company who's a supplier of materials, and that's got to always be a benefit, and a benefit when you're talking to customers. So you're focusing more on the high temperature materials with Heraeus. There obviously is a great market for that with new products.
Yes, I mean it's very power module focused, so we're looking at everything that is for high temperature, for high reliability applications, and also a little on the pricier side most likely, but it's in the inverter business, for automotive, for traction, for photovoltaics.
But all of the materials for that market generally have been more expensive than the norm, and sometimes customers sort of query the price, but other products or other solutions for the high temperature have always been slightly higher. And as long as you find a solution, you're providing a solution, a total package if you like, I think that it's justifiable.
Yeah, I mean it's also a lot due to the materials used. I mean there's silver inside, there's copper inside, there's palladium sometimes, or other precious metals. There's also gold bond wires, and by definition there's no way to make them cheaper also for the competition.
Well, and make them reliable, which is the key thing. For most of your customers, reliability is number one, and then perhaps the other things fall into line. So in terms of customers that you've been talking about or visitors to the show so far, what's the number one question they've been asking you?
I guess there's been a lot of interest in the die top systems that we offer, because people have been getting kind of news that maybe some people are using them already, which is true. One of the big automotive suppliers is using this in series production, and it's basically a system that allows to bond with copper wires on top of silicon carbide chips that are fairly brittle and fairly sensitive, so it's kind of a bond buffer, so it protects the silicon carbide chip from the bonding of the copper wire, and then allows you to use the more powerful, the more conductive wire instead of the soft aluminum wire on top of the silicon carbide chip, which increases the lifetime of the setup by a factor of 50 or even more, so it's really helpful.
And what sort of temperatures are we actually talking about? We all use the term high temperature. First of all, high temperature in terms of processing, but also high temperature in terms of application. What sort of temperatures?
It's actually in terms of application, and we're talking about 175 to 200 degrees or maybe even above that. But classical technology was like around 150, so we're 25 to 50 degrees above that in the actual operating temperature.
So with your previous experience that I've asked you about, what have you taken from that previous experience? Void formation obviously was probably one in the past, but as you're using a different technology, perhaps voids is not an issue with the type of sintering technology you use today?
Voids is actually not the most interesting, but I mean all the technologies to check for the reliability, such as shear testing or scanning acoustic microscopy, that's experience I've had in the past and that I can still use perfectly for the sinter technology today.
Yeah, it's interesting because I was watching a presentation earlier from a particular company, and I could see all the failure analysis stuff coming up and some great examples of failures. How can we learn sometimes from failure? Because, I mean, nobody wants to talk about it, but in reality it can happen, not with your company's products, but with somebody else's products. But how can we learn from failure? Because sometimes we just don't learn quickly enough.
I mean, that is the big challenge. I think openness between your own production and your customer and their production is one of the key aspects, because sometimes it's really a very little thing that's easy to change that can improve the reliability of the process very much. But it's something that's very difficult to get to because people don't want to be so open or so clear about what they really did. So exchanging as much information, at least with the customer who has these issues, as possible is really helpful. And then, I mean, we've done some reformulations of pastes in the past based on customer feedback. We've also been able, from customer feedback, to figure out what production parameters, for example, were fine and what were not. So, I think it's really the data exchange and the precise look statistically at what has happened that will allow you to find the failures and improve the process either at the customer or at our site.
Well, certainly I've experienced that once with an automotive supplier, only probably about 3 years ago. They had failures. I was brought in by the supplier to support him. They wouldn't allow the supplier to go on the shop floor, but I could go on the shop floor with the automotive manufacturer. But we're here to solve a problem. Well, we'll let you, but not him. And when you have a problem, you want as much help as possible because you've got to resolve that problem as quickly as possible. And again, do you find that, Heraeus must have an incredible range of technical equipment, failure analysis laboratories. You mentioned about the two different test methods you use. Are you innovative in that respect as well, trying to find new techniques to see quality changes in your products?
It's probably not our main focus, but we do have application centers that are very well equipped with everything you need for soldering or sintering and a lot of different analysis tools. And of course, we have partners from the analysis machinery, which we're in regular contact with, which we have tech days with, that tell us about new developments they've made, and we tell them about new problems we have, and that way, yes, we do improve this knowledge, but it's probably not our core know how to improve the analysis methods. We do have, however, as Heraeus, which is a big group, not just the Heraeus Electronics that I work for, we do have a central analytics department that has even more analytical capabilities and also very dedicated experts that improve their knowledge on the technology of failure analysis every day.
So if you were able to say one thing, one technology which you're either working on or you're introducing that's really excited you as an engineer, one thing, what's the prime thing that really interests you?
I mean, I think right now the most exciting thing is the large area sintering, because we're very well versed now in the die attach sintering, and it's becoming fairly common in the industry for silicon carbide already. And now we try to bring the technology to the base plate, which is a completely different challenge because it's a much larger area. It's much more difficult to cure without having any kind of channels to get the solvent out of it, and it's also very challenging because the warpage of the surfaces is usually higher, and so it's a really interesting challenge, and I think it can move the cooling of the power modules to yet another level.
Okay. Well, I'd like to say thank you very much for coming along, having a chat.
Thanks a lot.
It's nice to talk about a slightly different technology that I'm used to at higher temperature processing, but I wish you all the best for the show and your success in the future.
All right, thank you so much.